Hi guys, welcome back to my YouTube channel IBwontcrushyou, and today we're dealing with properties of functions from the chapter functions, and we will go through some exercise. So let's get started. Problem 1. Consider the function f equals square root of 2x minus 4. A. Determine the domain of f. And in order to do this point, we have to remember what cannot be under root, square root, or basically all the type of roots. So we remember that under the root cannot be negative number. So this 2x minus 4, this is what we have under our square root, has to be greater or equal to 0. So it cannot be less than 0. So no negative number. And now we can move negative 4 from the left hand side to right hand side. So 2x is greater or equal to 4. And now we can divide both sides by 2 and we're left with this. So basically this is our domain, or we can write it also like this. So x from close to infinity. In B, we have to use our GDC to sketch the graph. So we have to type our function, this function, into our GDC graph function, then draw it and then redraw it on the paper. And this is our graph. We have to remember that our graph starts from 2. So here is our starting point and then goes to infinity. C, from graph estimate the range of f. So now we have to consider what is going on y. So from our graph we can observe that our graph starts from y0, because here we have y0. It is x2, however, y0, and then goes to infinity, because here it goes higher, and to infinity. So our range for y is y greater or equal to 0, so y from 0 to infinity. Problem 2, let h be equal to negative x squared plus 6x plus 2. A, use GDC to find the vertex of the function. So basically all we need to do is to type our function into GDC and then just choose gsolve and then maximum or minimum point. We have to look at our function and decide whether we have maximum or minimum point. So this is our function. Our function is parabola, and we can observe that our parabola has a maximum point in here, and from the GDC we can find it, and this maximum point is 311. And in B, state the intervals where the function is increasing and decreasing. So we can observe that from minus infinity to 3, our function is increasing. And from 3 to infinity, our function is decreasing. So these are our answers. And C, explain how these intervals relate to the gradient. So firstly, we have to remember that when our a, so the digit in front of our x squared, so in here we have minus, so we know that this is minus 1. So when we have something negative in front of our x squared, our parabola looks like this, so like ours. when we have something positive in front of our x squared, our parabola looks like this. And now we have to recall our general formula for the quadratic equation. So y equals ax squared plus bx plus c. And now we have to also remember about the formula for x in the vertex. So for this x, and this is x equals minus b over 2a. And now we have to check whether our x will be the same. So we have to substitute our values into our formula for x in the vertex. So x equals minus b. B is in here, so minus 6 over 2 times a. And our a is in here, so this is negative 1. So times negative 1. So we have minus 6 over minus 2. So our final answer is 3. And this is the same as our x in the vertex, so 3. Problem 3. Let f be equal to x squared plus 2x for x from negative 3 to 1. A is this function 1 to 1 on the given domain. Justify graphically. So firstly, we have to say what is 1 to 1 function. A 1 to 1 function is when we have one output connected with one input. So basically each x has one y value. So each x is connected with only one y. So now we have to type our function into our GDC, draw it, and then redraw on a paper, and then check whether each x has one y. So this is our function, and we can observe that our function is not one-to-one function. And if you cannot see it, you can also draw a line, a straight horizontal line like this. And if we have more than one point of intersection of our function with this straight line, if we have more than one, it means that our function is not one-to-one. If we have only one, our function then is one-to-one. B. Find the inverse function f to the power of minus 1 algebraically. So our function is fx equals x squared plus 2x. We can also write it as y equals x squared plus 2x, because we treat fx like y. So we can write it like this. And if we have inverse function, our this f to the power of minus 1 works like x, and this x works like f. So basically they are switched. So now we have to do the same in our function. So our y, we switch it with x. So we have x equals y squared plus 2y. So we have basically the same function, however our letters are switched. And now we have to designate our y. So we have to do everything to have y equals. However, the right hand side will be different, but we have to do like this. So our y is equal. And now normally we would take y in front of the bracket and then the next steps. However, here we have to see that this is a half of our shortened multiplication formula, and in order to have a full shortened multiplication formula, we have to basically add 1. However, when we add 1 to our one side, we have to also add 1 to the second side. So we have x plus 1 equals y squared plus 2y and plus 1, because it doesn't change anything, because if we want to move this positive 1 from our left hand side to right hand side, we have negative 1 on our right hand side. So basically this is 0, so it doesn't change anything. So now we have x plus 1 equals, and now we have to use our shortened multiplication formula. So in this case we have in the bracket y plus 1 and the whole bracket squared. So once again, to designate our y, now we have to take the square root of both sides to eliminate this power. So square root of x plus 1 equals y plus 1, and we have to remember that we don't know if this value in the bracket is positive or negative, so here we have to include plus minus, because we're not sure whether this final value of y plus 1 is positive or negative. So in our case, for now we have to leave it like this, and now we can move our 1 from the right hand side to left hand side. So minus 1 plus minus square root of x plus 1 equals y. So y equals minus 1 plus minus square root of x plus 1. And here, because our domain is from negative 3 to positive 1, we're left with y equals minus 1 plus square root of x plus 1 because of our domain. And C, sketch both f and inverse function of f on your GDC and verify that they are reflections across the line y equals x. So the red line is our inverse function. Our dotted purple is our line y equals x. So we can observe that they are symmetric about this line, and here we cannot draw our inverse function because our domain doesn't allow us to do so. Problem 4. Let f equals square root of x plus 2 and g equals 1 over x minus 3. A. Find fg and simplify. And it means that we have to somehow connect our functions. Firstly, in first place we have f, and in the second place we have g. So our function works like this. We have f, and in bracket we have g, and then we have x. So our function g is like x. So to our function f, so x plus 2, we substitute g as x, so the whole fraction. So 1 over x minus 3 plus 2, which is from our function f, and this is our final answer. It says that we have to simplify it, however, we cannot do much with it, so we can leave our function like this, and in B we have to determine the domain of our function. So first thing first, we have to remember that our denominator cannot be 0 because we don't divide by 0. So our x minus 3, so our denominator, cannot be 0. So our x, when we move our negative 3 from the left hand side to right hand side, will be 3. So our x obviously cannot be 3. And the second condition is that our square root, so everything that is under our square root, cannot be negative. So here we can write our sign for and. So and, because we have two conditions. So our 1 over x minus 3 plus 2 has to be greater or equal to 0. And now we have to simplify it. And firstly, obviously, we will move our positive 2 from the left hand side to right hand side. So we have 1 over x minus 3 is greater or equal to minus 2. Then we have to multiply both sides by our denominator, so by x minus 3. So here we are left with 1 is greater or equal to minus 2, and here we have a bracket with x minus 3. So now we can do multiplication. So here we have the same, here we have minus 2x plus 6. Now we can move our negative 2x from right hand side to left hand side, and our positive 1 from the left hand side to right hand side. So we have 2x is greater or equal to 6 minus 1. So we're left with 2x is greater or equal to 5. And now we can divide both sides by 2. So x is greater or equal to 2 and a half. And this is our final domain, including these two conditions, that our x is not 3 and our x is greater or equal to 2.5. And we can write it down like this, or we can also write two intervals. Depends how you just like writing the domain. And this was the last problem from this topic, properties of functions, from the chapter functions. And if you found this video helpful and useful, please leave thumbs up, subscribe to my channel, and in case of any questions or any doubts, feel free to reach me out in comments down below or via my mail that is in the description of this video. See ya!